Hey guys, Mr. Fraser here from NeonMaths. This is the second video I'm doing on straight line graphs. The first video I looked at plotting straight line graphs, and in this video we're going to be looking at what m and c represent in the general equation y equals mx plus c. Once you understand what to do in these questions, your life is going to be way easier. You'll be able to draw graphs quicker, you'll be able to interpret them a lot faster as well. So, if you don't like straight line graphs, you're in the right place. I'm going to show you how easy these can be.
Fractions when they come up with the root sign down. Lethal weapon in your mind, like a gun without a sound. No shortcut, no mark scheme, quit your chattering. It's your discipline, lets you stay true to your regimen.
Okay, so let's talk a little bit more about the general equation of a straight line graph. Well, the general equation of a straight line graph takes the form y equals mx plus c. M and C are numbers. They can represent any number, but they tell us something very specific about the graph. We're going to learn a little bit more about that. So to start with, I'm going to put some graphs up for you to consider. Let's have a look at y equals 2x, y equals 2x plus 2, y equals 2x plus 7, and finally y equals 2x minus 5. And what do you notice about those graphs? Well, they're all parallel to each other. And they're all parallel because they have the same steepness. Now, in maths, we have a special word that we use to describe steepness, and that is the gradient. If you have a look at the equations of these graphs, you'll notice that the number before the x is always the same. In each of these cases, it's 2. That number is the gradient of the line. The number before the x represents how steep the line is. If it's a really big number, it's going to be really, really steep. If it's a really small number, less than 1, it's a fraction like a third, it's going to be far less steep. So now we understand what part of the equation represents the gradient. Let's look at these graphs over here. Let's have y equals 5x plus 3. Y equals, let's just do x plus 3. Y equals a half x plus 3. And finally, let's do y equals negative x plus 3. Now, what do you notice about these graphs? Well, first of all, you'll notice that they each have different gradients. None of them are parallel this time. And you'll also notice that they all cross the y-axis at exactly the same point. In fact, when we have an equation in the form y equals mx plus c, this number over here tells us where the graph crosses the y-axis. We call that the y-intercept. So that's it. Y equals mx plus c is the general form of a linear equation. The coefficient of x, the letter represented by m, is the gradient, and the y-intercept, c, tells us where the graph crosses the y-axis. Okay, so what is the gradient? Well, we talked about the gradient as the steepness, the slope of the line. So how do we work out the gradient of a line? Well, many of you will have already learnt do rise over run. But I actually prefer to see that. It means exactly the same thing as delta y over delta x. Delta is just a Greek letter, and it represents the change. So I would read this as the change in the y-axis divided by the change in the x-axis. It means the same thing. Change in y-axis is how many it goes up or down. Change in the x-axis tells us how many it changes on the run from left to right. So let's have a look at this question over here. Well, what's the gradient of that line? Well, if I pick the point, I can see that it goes 1 up and 3 across. So for that line, my gradient would be 1 up, the rise is 1, and the run is 3. So the gradient would be 1/3. Let's have a look at this one. Well, this question goes 4 up and 2 across. So 4 over 2. Well, that simplifies as 2. So the gradient of that line is 2. If you look at it, from the bottom corner to the top, it goes 2 up, 1 across, 2 up, 1 across, or 4 up, 2 across. Both of those simplify to a gradient of 2. Let's have a look at our last one. Now, this one's a bit different to the other ones. Why? Well, it's not going from the bottom left to the top right. It's going from the top left to the bottom right. This has a negative gradient. We're going to learn a little bit more about that in a minute. But for now, we can see that it goes 6 down and 3 across. And that can be simplified to 2 down, 1 across. And if you look from the top, 2 down, 1 across, 2 down, 1 across, 2 down, 1 across. All the way along that line, everywhere has the same gradient. So remember, we need to work out the gradient, and we do that by doing our rise divided by our run. So the coefficient of x tells us the gradient. It tells us how steep the line is. Well, is there a difference between having a positive or a negative gradient? Absolutely, there is. In fact, when we get a positive gradient, our graph looks a little bit like this. A negative gradient, our graph looks like this. And we could also have an equation that doesn't have a gradient, and they look like this. Now, how can you remember that? Well, one of the ways I remember is I think to myself, well, can I make a tick? Okay, I'm right-handed, so I do my ticks like that. If I can, it's a positive gradient. Well, that one, capital N, I make it look like a big capital N. If I get a capital N, then I think it's a negative gradient. Okay, so let's try and see if we can put this understanding into practice. I'm going to put up a straight line graph on a Cartesian plane, and together we're going to determine what the equation of that graph is. So let's have a look at this one. Right, well, good place to start might be to look at where it crosses the y-axis. That's pretty straightforward. In this case, as you can see, it crosses the y-axis at 3. So we know my equation for that graph would be y equals, well, it's going to be something x plus 3. The number on the end, remember, is our y-intercept. So now all we need to do is try and understand what the gradient is. So let's pick 2 points. Now we want to pick 2 points where my line crosses both my x and my y axes, i.e. not halfway along. We want to find it in exact coordinate. Well, this one goes 2 up, 1 across. So I could write my gradient as my rise is 2 and my run is 1. Now I hope that we all know that we can simplify that to 2x plus 3. And that is the equation of my graph. Let's have a look at another example. This one crosses the y-axis at -4. And if I look at the gradient, my rise, my delta y, my change in my y is 1 up, 2 across. So let's put that together now. My equation for that straight line must be y equals 1/2 x. And let's have a look. It crosses at -4. Right, and this is the last question that we're going to do. What is the equation for this straight line? First thing you'll notice is that it has a negative gradient. But apart from that, everything else stays the same. So let's have a look at my gradient, my change in my y divided by my change in my x. Well, this one goes, well, it doesn't go 4 up, but it goes 4 down, so it's going to have a negative, 4 down and 5 across. We could write that as 0.8, but my equation for this line is y equals -4/5 x, and then we need to look at where the graph crosses the y-axis. So now you know what m and c mean in the general equation y equals mx plus c. I hope you're able to use it and to wow your friends and your teachers in your maths lessons. Maybe, maybe not. But it is a useful skill. It's really good to be able to do it. I hope you found this useful. If you do, please subscribe to my channel. This is NeonMaths. Good luck.